Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 12th grade topic, finding your explicit formula for your geometric sequence. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use it to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today, or even your own homework, you can always put in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I've been linking my 12th grade playlist, in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video is only going to have 2 parts, so leave a like, smash subscribe, and let's get started! In today's video, we're going to be finding our explicit formula for our geometric sequence. Now, if you've seen my video on how we found our explicit formula for our arithmetic sequence, the method is going to pretty much mirror that. Now, if you hadn't seen that, no worries, you can find it right up here. But in today's video, we're going to be taking pretty much step by step how we're going to find our explicit formula when we're only given an arbitrary nth term and our common ratio. So for this example, we see we have a sub 4, our 4th term of our sequence, equals 25, and our common ratio is -5. We want to find our explicit formula from this. So the first thing you want to do is write out the explicit formula in general form. We're not going to worry about what the specifics are. This is just giving us a roadmap so we know what we're trying to aim for. So we know that a sub n equals a sub 1 times r to the n minus 1 power. This is our general form of our explicit formula. We want to fill in this as much as we possibly can. So notice we already have our r, which is -5. All we're missing is an a sub 1, our first term. So let's find our first term using this formula here. So we know we have a sub 4, our 4th term. So if n is going to equal 4 in this case, if n equals 4, then we can actually write out this formula like this. A sub n is going to be a sub 4 equals a sub 1, we don't know what that is, times our -5 in parentheses, and that's going to be raised to the 4 minus 1 power. So we can rewrite this because we know what a sub 4 is. 25 equals a sub 1 times our -5 to the 3rd power. Now we're doing it this way because this formula gives us our a sub 1. If we solve for a sub 1, we will find our answer and we can fill in the last missing piece. So that's why we start with this formula here. So we're pretty much using your explicit formula to solve for your explicit formula, just like we did for our arithmetic sequence. Now if you were to expand that out, that'll be 25 equals a sub 1 times a -125. Now solving for a sub 1 is going to be 25 over -125, which is going to be a -1/4. Nope, not 1/4, -1/5. This is going to be a -1/5. So we're not done. We know our a sub 1, but we want to find our explicit formula for this geometric sequence. And technically, we just have our general form. So let's plug in our a sub 1 and our r to find what the explicit formula is going to be for this particular sequence. So now we have all 3 components that we're going to need to find our explicit formula for this geometric sequence. We have our general form of the explicit formula, we have our r, and we have our a sub 1. So putting it all together, we're going to have a sub n equals a sub 1, which is going to be a -1/5. So let's put that in parentheses, times a -5, our r, to the n minus 1st power. This is going to be your explicit formula for this geometric sequence. But let's jump into our next question just to get a little bit more practice doing this method. In this question, we have a sub 5 is going to be 2500, and we know our r to be 5. So we want to once again start with our general form of our explicit formula, which we know to be a sub n equals a sub 1 times r, let's make sure my n's look like an n, to the n minus 1 power. So I keep writing this out because it's good practice to write it out so you can remember what that explicit formula is, because you have a lot of formulas you're trying to remember. So if you keep practicing writing this one out, it may be a little easier to come to you when you need it. So we're going to do the same exact thing we did previously. So we know in this case our n is going to be 5, right? Our n is going to be 5. So we're going to write our a sub 5 equals a sub 1 times r to the fourth power, 5 minus 1. And we know what a sub 5 is. That's going to be 2500 equals a sub 1 times r is going to be 5, put that in parentheses, to the fourth power. Now if we expand this out, we're going to have 2500 equals a sub 1 times 625. Now you just want to solve for our a sub 1. Get it by itself. So divide both sides by 625. 625. And that leaves us with an a sub 1 equaling 4. Now that we know that a sub 1 is going to equal 4, we can plug in all our missing components to fill in the explicit formula for this geometric sequence. So let's erase all of this here and write our final explicit formula for this question. Okay, so we have our a sub 1, we have our r, and we have our general formula. So we're going to plug in all the missing components. That's going to be our a sub n is going to equal a sub 1, which you know now to be 4. You don't have to put that in parentheses because there's no negative there. Times our r, which we know to be 5. I would recommend putting that in parentheses just to kind of get into a habit. And we don't have to, but get into a good habit of doing that. To the n minus first power. This is going to be our explicit formula for this geometric sequence. Notice the key is just using your explicit formula to solve for a sub 1 so you can then plug it in to your explicit formula. Well, I hope you were able to follow along with today's video and hope you see that finding the explicit formula for your geometric sequence is going to be no different from how we did it for our arithmetic sequence. Just use your explicit formula to find your explicit formula. But if you have any questions about what we saw today, or even on homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel, but letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share the video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney. Here's your playlist, and this has been another session of Tutor Me Sempai.